Hey everyone, so now that we feel a little more comfortable with inequalities, we remember exactly what they are, we're going to start solving inequalities. So solving inequalities is almost exactly like solving equations. So we're going to take our skills from solving equations and we are going to solve inequalities using those skills. So when solving inequalities, solve using inverse operations, just like solving equations. Now, one very important thing that you need to remember, so definitely when you write this down in your notes, write it big and bold, is you're always going to flip the inequality symbol when multiplying or dividing by a negative. So we're going to take a look at that in a minute. So definitely write this down big and bold in your notebook. Okay, so solve for x. So what we're going to do is we're going to solve this equation as if, we're just solving it as an equation, and then we're going to take those skills and apply it to the inequality here. So it says x minus 3 equals 10. So hopefully you remember, same thing. We are going to draw train tracks because you guys know I'm a big fan of train tracks. Hopefully we'll... Okay, train tracks. Okay, so I'm going to do the same thing over here. I'm going to draw train tracks over here around that inequality symbol. So we're going to use inverse operations. So we're going to, the opposite of subtracting 3 is adding 3. So I'm going to add 3 to both sides. So that cancels, and we get x is equal to 10 plus 3 is 13. Okay, so with equations, right now we have one answer. X is equal to 13. That's the only number that if we were to plug it in for x would make this equation true. So now let's do the same thing over here. I'm going to add 3 to both sides. Same process. That cancels, so we get x is greater than 13. So I'm going to just write that again over here. X is greater than 13. Now, unlike the equation, there are many numbers that we can plug in here to make that true. So I need you to think about it. What are some numbers that make this true? So 14 is a number that makes this true. 20, 100, 13. Is 13 a number that makes this true? No, because we don't have that or equal to sign. So if this was a multiple choice question, make sure that you don't choose 13 as an answer, because 13, if you were to plug it in here, would not make this true. All right, let's take a look at another example over here. And just so we know, this can go on and on and on. After 100, any number between 14 and infinity, basically. Okay, so I put a little star here because now this is we're gonna apply what we talked about in step number 2 over here. So we have negative 6x is equal to 24. So we're gonna solve this, and I'm gonna start by drawing those train tracks. I'm gonna draw them here, and I'm going to draw them here. Hopefully you remember, negative 6x is the same as saying negative 6 times x. So we're going to reverse that multiplication by dividing negative 6 on both sides. So I'm going to divide negative 6, divide negative 6. That cancels here, and we're left with x equals 24 divided by negative 6 is a negative 4. All right, so negative 4 is the only number that if we were to plug it in for x would make this equation true. Now let's do that same process over here. We're going to divide by negative 4. We're going to divide by negative 6 on both sides. That cancels. So we're left with x. We have negative 4 over here. And I'm going to put a star because we divided by a negative number. Remember, if you divide by a negative number, you have to flip the inequality. So now instead of a less than or equal to symbol, we're going to have a greater than or equal to symbol. Okay, so we had to flip that inequality. You can see here that it had to flip. So I'm going to write flip also. Flip, flip, flip. Okay, so now our answer is x is greater than or equal to negative 4. So some numbers that are in the solution set, negative 4 is now included because we have that or equal to. -3 is bigger than -4. 0 is bigger than -4. 10 is bigger than -4, and so on. So we need to remember that to flip that inequality when we multiply by a negative. Okay, so before I solve this inequality, I actually want to show you something. So what I'm about to do has nothing to do with this inequality over here, this y plus 2 is less than or equal to 5. We're going to solve that separately. I just want to show you something. So let's talk about a regular inequality. Say we have 10 is greater than 5. We know this is true. That was one of our examples in the last lesson. 10 is a bigger number. The alligator is eating the bigger number. Perfect. This is correct. So now say we wanted to multiply both of these numbers by 2. So I'm going to multiply by 2. I'm going to go elementary school real fast. I'm going to multiply by 2. And we get 20 and we get 10. So does this remain true? Yes. 20 is greater than 10. Perfect. Now let's do the same thing. So I'm going to write the same inequality. And let's multiply by -2. And see what we get. 10 times -2 is -20. 5 times -2 is -10. So now, is this true? If we were to bring this inequality sign down, is this true? Is -20 greater than -10? And the answer to that is no. This is not true. So that is the reason why we have to flip that inequality when we multiply by a negative number. Because when you multiply by that negative number, the signs switch, which is going to make the values of the number switch. So please make sure to do that. Okay, so I just wanted to review that before we solve this, but we can start solving it right now. All right, let me just erase this so we have our room. But yeah, the goal of that was just to make sure you understand why we're multiplying by a negative number, why we flip it when we multiply by a negative number. Okay, so now let's solve this. We have y plus 2 is less than or equal to 5. So let's draw those train tracks and solve it exactly as if you were solving a regular one-step equation. So hopefully you notice we would subtract 2 on both sides. That cancels, so we're left with y. And we have -2 on this side. We did not multiply or divide by a negative number, so we're going to keep that sign the same. So we have y is less than or equal to, oh, what am I talking about? It's not -2. 5 minus 2 is 3. Sorry about that. So 5 minus 2 is 3. So y is less than or equal to 3. So numbers in this solution set are any number that is less than or equal to 3. So 3 is included here, 2 is included, 1, 0, and so on. Those are all numbers that are less than or equal to 3. Okay, let's take a look at another one. We have 11 is less than 3b minus 4. So start with those train tracks, kind of like built into your inequality. And let's start solving this two-step inequality. The first thing we want to do is move that constant. The opposite of subtracting 4 is adding 4. So let's add that to both sides. So we get 15 over here is less than. Those cancel out. And then we have 3b. Okay, last step here. Divide by 3 on both sides. So we get 5. We get b. We did, because those cancel out, we did not divide by a negative, so we're going to keep that inequality the same. So we have 5 is less than b. Now, I always like to write it so my variables are in front. So I'm going to switch this. This is the same as saying b is greater than 5. Both of these are exactly the same. But if you switch the order, you have to switch that sign too. I'm not multiplying by negatives or anything like that. I'm just changing this around almost as if we had x equals 10. That's the same as 10 equals x. I'm just switching things. 10 equals x. Not 10 equals 10 does equal 10, but just so I can see exactly, because this is how they would write it on the region. So numbers in this solution set are any number greater than 5. Remember, 5 is not included here. So 6, 7, 10, 20, and so on. Okay, let's take a look at one more example. So let's draw those train tracks. First step, let's move that constant. So let's subtract 6 on both sides. That cancels. We get negative 3x is less than 18 minus 6 is 12. Now let's divide that negative 3 on both sides to get that variable isolated all by itself. We're going to cancel those out. We get x. We get negative 4 over here because 12 divided by negative 3 is negative 4. And we did divide by a negative number here, so we're going to flip the sign. So now this becomes a greater than symbol. So that is our answer. Any number that is greater than negative 4. Negative 4 not included here because it does not have that or equal to symbol. So we have negative 3 is bigger than negative 4, 0, 2, 5, and so on. Those are all numbers in our solution set. Now, before we go, there's one other thing I want to discuss. I want to talk about two important mistakes that students make. So say we have let me just make sure we can read this 100%. Say we have 2x is greater than negative 10. If we solve this here, we're going to divide by 2 on both sides, and you get x is greater than negative 5. Now notice I did not divide by a negative number, but my answer is still negative. This answer, it does not matter what sign that is. If you don't divide by a negative number, don't flip the inequality. So that's a number one mistake students make, is they see, oh, my answer is negative, that means I need to flip the inequality. You only flip it when whatever number you're dividing by or multiplying by is negative. So please keep that in mind. The sign of the answer in the end, it does matter, but in regards to switching the sign, it does not matter. So please pay attention to that and remember this rule. This is a very, very important rule that a lot of students get tripped up on. So let's try to remember that and get all of these questions right.